Boost converter open and closed loop modeling. DC to DC converters are also known as choppers. Here we will have a look at the step-up chopper or boost converter, which increases the input DC voltage to a specified DC output voltage. A typical boost converter is shown in figure. The circuit consists of the input voltage source is connected to an inductor. The solid-state device which operates as a switch is connected across the source. The second switch used is a diode. The diode is connected to a capacitor, and the load and the two are connected in parallel as shown in the figure. There are two modes of operation. Mode I, switch is on, diode is off. The switch is on and therefore represents a short circuit, ideally offering zero resistance to the flow of current, so when the switch is on all the current will flow through the switch and back to the DC input source. Let us say the switch is on for a time t on and is off for a time t off. We define the time period t and fs as the switching frequency. Let us now define another term, the duty cycle, d, which is equal to t on by t. While performing the analysis of the boost converter, we have to keep in mind that the inductor current is continuous, and this is made possible by selecting an appropriate value of L. The inductor current in steady state rises from a value with a positive slope to a maximum value during the on state and then drops back down to the initial value with a negative slope. Therefore the net change of the inductor current over any one complete cycle is zero. Mode 2, switch is off, diode is on. In this mode, the polarity of the inductor is reversed. The energy stored in the inductor is released and is ultimately dissipated in the load resistance, and this helps to maintain the flow of current in the same direction through the load and also step up the output voltage, as the inductor is now also acting as a source in conjunction with the input source. Now we can proceed with the modeling of our boost converter. In open loop modeling of boost converter we are keeping duty cycle as 50%. The output voltage V out is equal to V in by 1D. Step by step I am showing all the value of components used in the circuit. The input voltage source, the inductor, the solid-state device MOSFET or IGBT. The second switch used is a diode. The capacitor, and the load. The circuit is completed by connecting all the components together. Now we can run the MATLAB model to observe the output voltage, since the input voltage is set as 24 volts by keeping the duty cycle 50%. The output value should be 48 volts. As it can be observed in the display block connected at the output. Now to just check again, we will just check by changing the value of input voltage from 24 to 28 volts. The output voltage should be 56 volts. We can see the approximate value at the output. Now we can test the closed loop control of boost converter. The components are of same value. The output voltage is controlled by taking the output voltage and comparing it by a reference value and passing it through a PI controller. A saturation block is used after PI controller, whose output is fed to the PWM generator, which controls the duty cycle. We can change the set reference point to the desired value. With this we complete the open and closed loop operation of boost converter. Thanks for watching. Do not forget to like, share and subscribe.